Hi, I'm Bob. You've seen me in such fine quality, epic chemistry educational videos such as What Do Atoms Have to Do with Chemistry? And Chemistry is Really the Study of Matter? Part 4. Okay, we're in the second half of Chapter 4, the electron structure of the atom. Or, hey, where do the electrons hang out? Great question. Well, electrons, in fact, have their own address. Every electron has its own location in the atom. Now, we didn't worry about that so much in biology, okay, or physics, but in chemistry, it's like real estate. Location, location, location. And the location of the electron is going to be determined by how much energy does it have. It's an electron that's got lots of energy isn't going to have the same location as the electrons like, no, very different. So we'll use an address simple example just that people know what do I mean by an address, a location. Name, location, city, zip code, country. I really should add in state. But Grandmaster C, Avenida del Hombre, number 42. Playerstown, California, 14288. That would be an example of an address, the location of Grandmaster C. USA, country. Can't forget that. So when we look at electrons in atoms, well, there's a system. Now, it's made up of basically 4 quantum numbers, and that's it. Okay? There is the n, which is the principal number, and that's basically the distance from the nucleus. This is the part that dude Niels Bohr was correct about. Remember that picture I showed you, how happy he was? Because he was right about that. Everything else he wasn't right. But that was a big piece to the puzzle. But the second thing, so n is the principal, think what Bohr did, then there's L, there's angular, the shape of the orbital. You'd say, but wait a minute, whoa, 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 whoa. What's an orbital? An orbital is an area. It is a three-dimensional area. It's a volume where the electron could be located at any one time. Okay? So there's the principal level, which is the distance from the nucleus. How far is the electron from the nucleus? There is the L, which is the angular. It's the shape of this region where the electron is hanging out. The M is for the magnetic. That's the orientation in space of this orbital. Okay, it can be located in a different way. Okay, this is an orbital, for example, is it located like this? Is it located like this? Or is it located like this? There actually is a difference. And then the last one is S. S is for spin. Wait, electrons spin? Yes, they do. More on that for a moment. Okay, so here we go with our principal quantum number, n. Okay, and as you can see on our beloved thing here, okay, we have our nucleus, n equals 1, n equals 2, n equals 3, n equals 4. So we have 4 energy levels here. The higher you go, okay, the more energy you have. Now, also the higher you go, if you notice, the levels get larger in size. That's because you're being further and further away from the atom. Pretty much. So that's our principal energy level. And we can go up to about 7 or 8. But for what we're going to do here, we're going to look at just 7. That's it. So n could equal 1, 2, 3, 4, 5, 6, 7. Like that. Yeah. We can go with that. Okay. The L number. The Azimuthal Quantum Number. Whoa, 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 whoa. Azimuthal Quantum Number. Just think of it as the shape of the orbital that it's in. It's also known as the sublevel quantum number. Okay? Those are sublevels inside the principal level. Now, the principal level, an example is n equals 2. Okay, so L could equal, well, there's a possibility here. For each value of n, there are n possible values ranging from 0 to n minus 1. Okay, so if we look at n equals 2, we know that there's n possible values. It ranges from 0 to 2 minus 1. So for level 2, you're either going to have an L number of 0 or 1. That's it. Now, personally, I find letters are way easier to describe than numbers, okay? And here we are. We have the following 4 letters, S, P, D, and F. Okay, what about these letters, S, P, D, and F? What do they tell us? Everything. Ooh, so what are they? Well, if you notice, here we have got ourselves a red sphere, and you'd say, look, there's an S right there. You are right, that is S. Then we have the P. Now notice the difference between the shape of the orbital of S, that region where electrons hang out in the S, compared to the P. Okay? Notice the P sort of looks like 2 eggs that are stuck to each other, and where they're joined right where the X, Y, and Z axis meet at that one point. Yeah! Can you imagine that? Now, here's the kicker for it. This is true for every atom. Oh! Then you have the D sublevels. Now the D sublevels, and if you notice, they don't look exactly alike. If you look at this one here, it looks like a donut between 2 eggs. Weird. How do we even know that these levels, what they look like? Answer. What the electrons are doing, how are they behaving? That's the key. Think. Think about what's going on here. Electrons hang out in regions. If we have one person go to Ontario Mills and they had the whole mall to themselves, what would that look like? If we took a picture at 7 o'clock in the morning, noon, 7 o'clock in the evening, where would they be? And that's just it. They're going to be in different places, most likely. At 7 o'clock, they may be hungry. They may be getting breakfast at the food court. And then maybe at 8 o'clock, maybe they're going to go and catch a movie. I don't know. That gets into another story. But as you guys can see here, if you notice, the S looks just like a bouncy ball. Boingy, boingy, boingy. Here's the P with 2 eggs stuck next to each other. Here we have the D. You know, they're kind of a little bit weird. And then, oh my gosh, if you look at the F, just look at the F, man. Just take a look at those little green things right here that I'm highlighting with my laser pointer. Wow, these look like that circus act with balloons that they could tie into making the funny little animals, right? Yeah, sorta, kinda. Yeah, moving on. So the letter refers to the shape of the sublevel orbital. Okay, notice we didn't say, n is 0 and n equals 1. Now for level 2, there's only 2 possible sublevels. There's sublevel S, where every level has a sublevel S. It's automatic. Okay, level 1, you got a sublevel S. That's it, nothing else. Why? Well, because it is the one that's closest to the nucleus. Level 2, you've got, well, let's see, n equals, well, you got 0 and n equals minus 1. N is 2 for the level, so 2 minus 1 is 1. So we got 0 and 1. Well, what's 0? 0 is this. Whoops, go back. 0 is this, and 1 is this. That may look a little confusing. This is why, personally, I stick with letters. They're easier. On level 1, you got S. End of story. Level 2, you have 2S and 2P. Okay? You'd say, well, what's going on with, there's 3 different P's there, and they have these different, like P to the minus 1, P and the 0, and P to the 1. What is all that? think of it as the orientation. That would be our third piece of the address, is how is it oriented? So we looked at level, the first thing of our address is what principal energy level is it at? Then the second thing is, what's the shape of the orbital, the shape of the region that it's going to be at? Then the third thing we would have to look at is, how is that oriented? And that's where we use the X, the Y, and the Z axis. Pow! Okay, so let's move on. If we go look at it, for each value of n, there's n possible values ranging from 0 to n minus 1. So if you notice here, we're looking at our azimuthal quantum number, or the sublevel quantum number. For level 1, okay, well, 0 to n minus 1. Well, 1 minus 1 is 0, which means that there's only one sublevel in level 1. In level 2, notice we've got two sublevels. We have 2s and 2p. Now you'd say, but wait a minute, you showed us 3 of these p sublevels. What's up with that? We'll get to it. Don't worry. We will. Okay? Then we have level 3, where we've got 1, 2, 3, and level 4, 1, 2, 3, 4. And then level 5, we've got 1, 2, 3, okay, and 4. And you're going to start noticing, if you look at this, you'll see, wait, there's 1, okay, 1s, I got it. 2s, 2p, okay. 3s, 3p, 3d, okay. 4s, 4p, 4d, 4f, all right. Now, if you notice the arrow coming down here, it's telling us the order that the electrons will fill in these levels. But for now, we're just going to go and talk about our little sublevels, quantum numbers. Okay? So, N is our principal energy level. There's level 1, level 2, level 3, level 4. Then you have the azimuthal quantum number, also known as the sublevel quantum number. I like to use the letters S, P, D, and F. Those are the ones. Or is there a G and an H? Yeah, but we're not worried about that. Okay? Now, what about the magnetic quantum number? That's M. Well, if you notice, it talks about the spatial orientation. Well, wait a minute. What's the spatial? What do you talk about the spatial orientation? Well, what if I took an object that everybody would know, like this dry erase expo marker? If you notice, I'm holding it in the upright position. This is one way to look at it. It's standing straight up. Here's another way to look at it. It's lying on its side. If you look at it this way, it's lying directly facing the camera. Okay? That's a spatial orientation. So we can look at the y-axis, the x-axis, and the z-axis. We could also flip it around and look at the other side of our expo marker. Another example about how spatial orientation. I have here a penny. Notice the head is upside down. So we got the head. Flip it, and we have the back of the penny, the Lincoln Memorial. It's an old one. Now we can flip it again on its side, and notice how thin the side is. This is what we mean by spatial orientation. If we look at Ash Ketchum from Pokemon fame, for example, we can see that Ash here is the exact same figure Ash that people know and either love or hate, but you're looking at it from a different point of view. He is oriented a little bit differently. Okay, here is 2p in the x direction, 2p in the y direction, and 2p in the z direction. This would be an example of the magnetic quantum numbers. So, I am going to stop here because we're going to have to move on to part 2. Till then.